Hi, good morning, good afternoon to all our audience today. I'm Pankaj Barzai with the marketing team here at Impetus Technologies. I am your host and MC for today's session on this topic of how Apache Spark is becoming the new enterprise backbone for ETL, batch processing, and real-time streaming. A quick look at the agenda for today's session. We will be sharing with you the enterprise context of the requirement for a new data or enterprise backbone, how Apache Spark is serving that by covering some basics about Apache Spark and user concerns with respect to those. We'll be sharing some details that cover APIs, functionalities for ingest, ETL, and analytics, and more. And then we also present a demo on Visual Spark covering ingest, data quality, ETL, machine learning, both on-premise and cloud options. And then we'll move on to the live Q&A session. So before we proceed on the topic, I just want to have our audience understand a little bit about who we are. At Impetus, our mission is to create powerful and intelligent enterprises and for those who may not really know us very well, actually we are proud to say that many of North America's respected and well-known brands trust us as their strategic data and analytics partner. On your screen you can see some little logos or symbols down there. There's major airlines, major credit card companies, healthcare, telecom, and wireless companies and banks. And we're working with multiple verticals, and this topic today is applicable to all customers and businesses. We, as an organization, offer products including the Stream Analytics platform that we will demo today to you and in a little bit. And we also offer solutions and services to help you build the data-driven enterprise. We are headquartered in the beautiful city of Los Gatos, California. That beautiful little lake is a few minutes walk from our office where our speakers are sitting right now, Anand and Puneet, and we have our offices in India where 1,800 of our employees work across locations. We were founded in 1996 and have been profitable since then, a growing organization, and we have other interesting offerings that you can find more about on our website, www.impetus.com. Now, before we begin our webinar, a few quick housekeeping items to share. All our attendees today will be on mute, and you'll be able to hear the audio broadcast on your machine's audio system or your phone, wherever you're joining. You will be able to ask questions using the chat panel or the Q&A panel. In case you face any audio or video issues, please feel free to send us an email on events@impetus.com, and we will be able to address that through our operations team. We are now opening up poll question on your screen. The question is, how are enterprises currently using Apache Spark? You can respond to the poll question on the WebEx console on the right-hand side. What you see on the slide is the result of the same poll that we conducted in a previous webinar, where 120 people from the industry, 70% of them being from the Fortune 1000 enterprises, responded, and this is what they saw or shared about the Apache Spark usage. So kindly respond to this. This poll will be open for the next 15-20 minutes, and we'll be sharing the results at an appropriate time during the webinar session today. Right, a quick introduction for our speakers today, Anand Venugopal. He's the head of products and strategy for Stream Analytics, an open source powered enterprise grade streaming platform developed by Impetus Technologies. With over 20 years of experience in software innovation and business development for enterprises in the telco space, Anand is specifically passionate about solutions based on open source technology stack. And he's also a popular speaker. Some of you may have seen him at some of the major conferences as a speaker. Our second expert speaker is Puneet Shah. He's a senior solutions architect with Impetus and has been a key member of the core team that developed the Stream Analytics product and since then has been directly involved in all proof of concepts and implementations that we have been running for our enterprise customers, dating back to the announcement of this product, and most recently its full support for Apache Spark for over a year now. Now, to make this subject today a little bit more interesting, we'll be using two personas here as a part of the role play. The first persona is AV, as we fondly know. AV is playing a key influencer at a big bank called the Next Gen Bank, and he's usually satisfied with the current setup, prefers traditional vendors over others, and he's open to learning about new and considering new technologies. Puneet is playing himself as an Apache Spark user and believer, understands enterprise needs and legacy products. He's up to date and hands-on with the latest and best in Apache Spark, and likes to build it for real rather than talk about it. So without further ado, let me invite our first speaker. AV, over to you.
Thank you very much, Pankaj. I'm going to go right into the role play. This is Anand Venugopal, or AV. Hey, how are you doing? My name is AV, and I'm the head of enterprise data platforms at Next Gen Bank.
Hey, good to meet you, AV. I'm Puneet Shah. You could call me Puneet.
Thanks for that, Puneet. So what is it that you do? You seem pretty happy and cheerful.
Glad you noticed, AV. I have a feeling you'll be happy too when you hear this. I'm a big data solutions architect, and I just finished a project at a major bank. We used Apache Spark to build and deploy a cybersecurity data platform.
Wow, really? That sounds really good. What do you think that would make me happy, though?
Well, let me take a step back and ask you, what is it that you exactly do as a VP of Enterprise Data Platforms?
Good question, Puneet. So let me walk you through that so you get a context of who I am and what I do. So I'm actually the head of vendor and technology selection. I conduct evaluations and POCs for the end-to-end data processing platform that includes ingestion, integration, wrangling, predictive analytics, machine learning, etc. So you can see the whole shebang.
Okay. That's actually a lot of different things right there under your charge, AV.
Yeah, man, it can get pretty crazy at times.
Oh, I can understand. So tell me something. How many vendor products make up this entire mix?
Well, I can answer your questions, but you still haven't told me about your bank project with Apache Spark. I hear about it all the time these days.
Yeah, and rightly so, I'd say. Apache Spark is really hot. But before I come to that, can you respond to that? How many vendors you have under your data processing umbrella?
Well, so if you insist, here it goes, right? So I actually have, in my current setup, we have 1, 2, 3, 4, a total of 6 vendors. We got Matica Big Data Edition, we got Allen, we got Facta, we got Rackle Stream, Source Analytics, Rackle Big Data Appliance. As you can see, I mean, these are heavyweight best-of-breed enterprise vendors lined up. You know, they're all going to jointly take us into the new era of data processing.
Wow. 6 vendors, huh? And that too, I guess this is all in your department. Are you aware if there are other products or some of these also playing a role in other departments in your bank?
Well, embarrassingly, yes. I mean, we have other overlapping vendors and products in other departments.
Doing the same tasks, maybe?
Unfortunately, yes, again, it's in many cases, yeah.
Okay. By the way, how long did all of this take to build up?
Well, it took 3 years and a few $1 million to put all of this together. The architecture, blueprint for the whole stack, the project planning, the POCs, and finally getting it into a stable production state.
Wow. 3 years, huh? And few millions, you said. Did you figure out why it was so complex, why it took so time? What happened?
You know, you should know, right? I mean, we're not alone in this. I mean, I think everybody else is going through the same situation. I mean, you have such a large multi-vendor system integration, there are unplanned scenarios that end up taking time. It's a pretty complex deal.
No, I get that part, but tell me something. What's your big data plans?
On big data, we have a roadmap to move to the Oracle appliance, which has Hadoop built in. So,
nice. Okay.
So Puneet, we're all set, right? I mean, that's why they call us next-gen bank. I mean, we're always on, 24/7. Nothing can go down. We've got a trusted set of enterprise vendors. This is not an open source game, man. I mean,
Yeah. No, but hang on, not so fast, Avi. You haven't heard from me yet. Remember, I was going to tell you about my project?
Yeah, sure. Go ahead. I'm all ears.
Okay, but just one more quick question.
Okay, well, this is the last one, though, okay? We got to move on.
Okay, sure. So here's the thing. Besides reliability and always on, what else are your challenges or requirements? Like, tell me something. What does the business expect from you?
I think this might be useful for all our audience as well. I mean, it's really a big deal that business asks from us. They stall for a long time, but they suddenly want results. They want us to integrate the data silos. They want a single platform of truth, single source of truth. They want ubiquitous, fast self-service access to the data. And, they want to provide a platform for various use cases planned in our roadmap, right? So we got Customer 360 and, they want to do churn management. They want to do predictive maintenance of systems, fraud security, recommendation engine, real-time dashboard. So, the usual long list of use cases.
Okay. Got it. So this data platform that you're set out to build, it's if I understand, it's the basis for a lot of future innovation and growth in the bank. I think it's all the more a reason why you may want to choose a single technology for all these data processing needs.
Single technology? What do you mean? I mean, I don't get it. Please elaborate.
Sure. Let me do that. And honestly, believe me, I respect all of these enterprise vendors, all the names that you have taken so far. They are great products. I understand that. But I also understand that enterprises have far more complex landscapes. It's not easy. But you seem to be a little skeptical about open source. But let me tell you something from my experience. Open source systems these days are being widely accepted and deployed across many enterprises. They have been running open source technologies in production for quite a while now. And specifically with regard to Apache Spark, each and every one of our Fortune 100 or 500 customers that we work with, everybody is using Spark. It's pretty much in production for a while.
Wow.
Also, Spark is a versatile technology. It does so many things that you mentioned previously at the same time, like a single platform capable of doing all those different data processing needs you have. So let me tell you that big thing I was talking about. Are you ready for this?
Of course, man. You've been dangling that carrot for a long time. So, yeah, come out with it.
Okay. So here's the thing. This is how it plays out. You may not need this big multi-vendor scenario that you currently have if you leverage all the benefits that Apache Spark has to offer.
Whoa. Man, that's a radical statement. Are you telling me that you can replace all my vendor stack? What do you mean? Tell me more.
See, I told you. That's something that you would feel happy about.
Yes. Cut to the chase, Puneet. Give me an overview of the technology itself and its readiness, okay?
Okay. So this is what Apache Spark is. It's basically a distributed in-memory computing platform. It was originally open sourced in 2010. At that time, machine learning, Hadoop, MapReduce job was primarily what people used to operate on the big data Hadoop platform. Spark emerged as a contender to that and proved itself to be massively scalable and operating at a much faster speed than Hadoop, like MapReduce jobs. In benchmarks, they literally showed themselves to be 30x faster. And that's what happened in 2010. Over a period of last 8 years, Spark has significantly emerged and evolved as the single big data choice of platform for various needs, because now it supports, in the current state of how it is, it supports high-speed batch ingestion. It also supports your streaming needs. So imagine a single platform doing batch processing, doing streaming. It sits on top of your Hadoop infrastructure itself. So all the investment that you made so far in bringing in Hadoop in your environment, you can still continue to leverage that. It operates in a micro-batch paradigm. The latest version of Spark also supports continuous streaming, so you can actually do discrete event processing as well. And the good part is it also runs in a hybrid fashion. You can run it on-prem or on cloud, which we see a pattern emerging in a lot of enterprises also nowadays.
You know, that last point is so important because I was going to ask you, me and my colleagues in other banks, we're all either now or later moving to the cloud for sure. So are you sure this thing can work on both and potentially a hybrid environment?
Oh, absolutely. If you check any of the cloud vendors, like Azure, AWS, you'll see Spark being offered and supported by these vendors. There are a lot of other banks that I work with personally who actually have also moved a lot of their Spark-based workflow to cloud. So yeah, believe me, it does.
Wow. I mean, you seem to be really, really passionate about this. It sounds good. I mean, you know, when open source technology starts in Google and Yahoo and Facebook, all of these things sound great, right? But, you know, I got a job to do, man. This is an enterprise. This is a bank. This tech deep dive is good, but what I'm really interested in is, however, your practical experience of running it in large enterprises.
Sure. I think that's a fair point, and I expect it. I hear it all the time, and especially in enterprises. Whenever you talk about a new technology, they have their own fears and risks to worry about. So let me tell you something about the project that I was doing and why Spark is in reality enterprise ready. It's fault tolerant. So no matter what happens, even if a single node goes down, the job continues to run. It supports exactly once, so there is no fear of reprocessing your data and getting wrongful or duplicate records in your data lake. It supports back pressure and dynamic scaling, so even if there is a certain burst of data that suddenly comes in, it can scale up in order to cater to that additional load, and also scale down when the load is much thin. Of course, it's performance. That's the reason it became so popular back in 2010. And it's elastic. Like I said, it can scale up, down at any point in time.
You know, this is great, but have you done any real deployment of this in enterprises? I mean, where all of this is really working, all of this theoretical stuff that you're telling me?
Of course. Let me tell you a bit more about that, but of course we have. So we did a deployment in a major US airline company. Just on a 3-node cluster, we were ingesting 4 terabytes of data per day. Ingesting complex data coming in, parsing those out, putting them into an indexing store, and offering a UI to the business to literally query that much worth of data. They transitioned to Spark from a conventional technology, and they couldn't even think about querying on data of such a high volume over a long duration of time. Spark changed that. We deployed at another US bank this cybersecurity use case I was talking about. We did this entire installation of not just Spark, but also the other ecosystem in the big data like Kafka and Spark and one of our own products, Streamatics, all of that on a shared 4-node cluster, and yet we were processing about 200 million records a day. And the logic was pretty complex. It was a complex event processing use case where you were getting data from about like 2,500 different applications, and you had to look through those events as they keep coming in, look for patterns, do alerting on certain situations of pattern detection and stuff. So it was a complex project for sure. Another one was in a US telco 4-node cluster processing 100 million records a day. This was around a contact center analytics, and all of these that I'm talking about are actually running in production. So none of these are like something running in the labs or a POC stage.
I mean, this sounds great. 3, 4 nodes, 4 nodes. You're doing a lot of capacity on a limited number of nodes, but don't you have any larger case studies?
No, we do, of course. These are pretty recent ones that I just did, so I brought those up. But we have seen deployment ranges all the way from like tens of nodes to up to like hundreds of nodes of Spark cluster running in production, all stable over several years now.
Wow. I mean, you're really beginning to convince me now. This is giving me more confidence, I must admit. But I still don't get the bold claim you made earlier, Puneet. You know, how can you replace all my traditional, proven enterprise vendor stack with Spark. I still don't get that.
Sure. Let me try addressing that.
Well, before that, let me tell you a little bit about why I'm skeptical, right? So I got a bunch of data challenges to solve, right? I have large-scale ingest to do in our data lake, and potentially now ingesting data, some part of the data into the cloud, some part of the data into the data lake. I got to worry about ingesting from hundreds of different sources. Some of them are streaming too,
sure.
right? I got to do data quality because the business wants that. I got to do transformation, blending, enrichment, analytics, loading up different data stores, visualization, self-service data access, governance. I mean, this is a very, very large, comprehensive functionality set.
It is absolutely, and this is not just you. This is a very common pattern you would observe with any enterprise production grade use case. So, and let me tell you how Spark helps you with all of this, right? So you must have heard the term Data 360, essentially, which covers most of your entire journey that you described, all the way from ingestion, doing data quality, transformation, blending, analytics, getting the data, clean data into your data lake, and of course, doing reporting and visualization on top of that. So Spark literally has APIs and specific modules built to address all of these different aspects of a Data 360 journey.
Wow. Okay, so can you take me through that?
Sure. So let's on a quick overview, let's look at ingestion for a moment. So Spark has inbuilt connectors to read data from wide range of sources. So if you're sitting on cloud, for instance, you have connectors, depending on who your cloud vendor is, you have connectors to read from S3, you have connectors to read from Kinesis, you have connectors to read from Redshift, DynamoDB, and plenty of them. If you are on Azure, then you have blob storage, you have your SQL servers sitting on Azure, so you have connectors to all of those. If you're on-prem, you have connectors to read from HDFS, high file systems, even streaming sources like Kafka, MQTT for IoT, and so forth. And believe me, this is a very, very small list of what in reality the connectors are available. This is just a few popular ones. The community is huge. People are contributing every single day, adding more and more connectors to this. So pretty much there would rarely be a case where you would find an ingestion system or a source to which you do not have a Spark connectivity.
Wow, that's impressive.
On the data quality side, again, Spark has more than about like 150, 200 different inbuilt functions that you can leverage directly to transform your data, to play with your data, process it in different formats. If you want to do things like string manipulation, date manipulation, masking, encryption, all of that is pretty much possible doing Spark. The structured streaming release version of Spark makes it even more richer in this space. So yeah, there's a lot of different operators available for the data quality. Similarly, on the blending side, if you have streaming data coming in, you want to blend it with data that's sitting on rest, Spark supports that. It has APIs to do that. The most recent version of Spark 2.3 also supports stream-to-stream joining. This wasn't possible before, but now you can literally join two streaming sources together. And of course, if you're doing something which is purely batch in nature and you have multiple batch sources that you're reading data from, you could blend those. This is a very common pattern that we observe when typically people want to denormalize their data and put it in the data lake for faster querying and reporting. All traditional joins that you would see in a traditional database-like system are available in Spark to do all of these operations that I just said.
Wow.
Again, on the transformation side, you have a lot of core API functions, but what's also interesting with Spark is it gives you a SQL-like language also to work with on the data that's coming in. So if you are somebody who's coming from the traditional database world who's very savvy with SQL-like scripting, Spark supports that. You could literally do your transformations using a SQL language or even using pure coding like Python, Scala, Java, etc.
This is what they call Spark SQL?
This is the SQL functions. The second one is basically addressing the Spark SQL, yeah. And of course, the one right below that is user-defined functions. Of course, it's extensible. You can write your own functions, plug those in, and execute on Spark in a distributed fashion. That's where you get your performance and throughput from.
What about analytics?
Analytics, Spark has really evolved in the analytics space over the last couple of years. I hardly know people who use Mahout or any other library for analytics. Spark has become a de facto choice, and also the support of Python or PySpark really makes it a great choice for data scientists who have pretty much created their models on Python. You can execute those Python-based models on Spark now using PySpark. Spark also has a lot of inbuilt data science analytics support functions like feature extraction, feature transformation, feature selection, a wide range of machine learning models, broadly categorizing as classification, regression, and so forth. So there are also, of course, other third-party analytics tools. So, for example, if you're using H2O as one of your analytical suites, it very easily fits and integrates seamlessly with Spark, so you can still use that on top of Spark in a distributed fashion.
Wow, it just brings a little thought to me. Can I actually use machine learning to do data quality enhancement?
You can, and it's a very interesting concept, and the terminology they use in the industry is called imputation of data. So if you have data coming in and it has some missing values, for example, some of your key columns or attributes do not have values to it, you can actually use machine learning to predict those values and fill that in before you push it down for processing.
Wow. What about loading databases? I mean, I need to load 5 or 6 different data stores, not just the data lake. So can I do that?
Of course. On the loading side, you have many things. Just like on the ingestion side, you had connectors to so many sources. On the loading or on the target side, you have connectors to far large number of things also to write into. You could be writing into any kind of file system like HDFS, S3, and so forth. You could be writing in different formats as well. You could be writing as a Parquet, Evro, ORC, and so forth. You could be writing directly into your RDBMS databases like Oracle, SQL Server, MySQL, Postgres, NoSQL databases, indexing stores, and more. So believe me, the list, again, right, what you see here is small. There's a much larger exhaustive list available as well.
Boy, I mean, you know what you're talking about, it seems like, for sure. They say one problem leads to the other, right?
Mm-hmm.
One thing that's coming up for me is with all of this functionality and coding that's needed, can I really do enterprise-grade systems with Spark? The low-level nature of it makes me worry about finding the right talent, to execute and manage all of this Spark-related work.
No, I understand your point. You are right. If you already have a talent pool inside your organization and they are still not so much into Spark and the big data ecosystem, or maybe even if you have a few Spark developers, how do you scale that out? I get that completely. And that's why there are a lot of tools out there. I would recommend a Visual ID tool, which would make not just your developers, but to some extent even your business users be able to create their own analytics and their own data exploration kind of pipelines in a visual fashion. So literally, even if they do not have so much of a hands-on with Spark, like of course they wouldn't have hands-on on Spark coding, but even if they are not so much savvy about scripting and stuff, they can still use a visual platform to build out the application. So a Visual ID,
Visual ID for Spark?
Yep. It makes lives of developers easy, tremendous productivity gain, and not just developers, even the business analysts and the business community can also kind of start dabbling.
Wow, so you're saying I don't need to do all of this stuff that I was showing here, worry about the DevOps, debugging, version management, multi-tenancy, all of that. You got that covered from, moving from dev to test to production. I got to worry about a lot of things related to DevOps, development, operations of Spark, if I use Spark.
Yes, all of this is covered, but imagine for a moment all the Data 360 things we just discussed. Imagine for a moment if all of that is available in a visual fashion wherein you can simply drag drop and build it. What would you think about that?
Are you willing to show me this?
Absolutely.
Okay, well, here we go. I'm making you the presenter, so show me what you got. I mean, you better live up to all the promise you created here, man.
Sure. So what you're seeing here on my screen is Stream Analytics. It's a Visual ID for Spark. In fact, its tagline is Apache Spark made easy. The value prop here is you have a canvas like this with all these different operators on the right side and categorized as channels, processors, analytics, emitters, which you can drag drop on this canvas, connect them, configure them, and then just build out your entire Spark workflow on the fly. Let me walk you through a sample use case that I built here. This is bringing in New York taxi data. It's a publicly available data set, very common. So I built in a pipeline that's getting in the taxi data. I also have inside of this demo a demonstration of how you can plug in your Python-based machine learning algorithm. In this case, I purposefully chose imputation, the point that you were making earlier of how we can use data science for data quality. So we're using a Python-based model for data imputation. I'm joining the incoming data set with another data set to enrich and add additional information, operating and doing some data quality checks, doing some more expressions and transformations, and finally landing it into Elasticsearch. And also on a different fork, I'm doing some amount of aggregation to find out what's the most expensive route between two different parts or zones in the city. But right before I get into that, quick overview. On the right side, we see these four categories, channels, processors, analytics, and emitters. Each one maps to different journey inside of the data 360 terminology. Channels are your ingestion sources, so you can ingest data from one or more of these different sources. Of course, if you do not find one of the sources on this list, the platform is extensible. You can go ahead and write your own channel or your own connector. In fact, Stream Analytics had been awarded a patent in this area for extensibility. The next category is processors. So once you get the data in from your source, you want to do different kinds of transformations. You want to perform different kind of logic on the data. You would drag in one or more different processing operators for that. Analytics is different machine learning algorithms that are available that you can drag drop on the canvas and to build out your machine learning. And again, all of this can happen on batch and streaming sources both. So depending on what your use case is, doesn't matter, the user experience remains identical. You would change your source from, let's say, HDFS to Kafka if you were doing a streaming use case. And lastly, the emitters, these are the sinks to which you can write your final output into. And now, having said that, let's take a look at the left side of the screen. What we see here is this pipeline that's been dragged. We also see a panel below. So what we have done here is, as part of building your Spark workflow, and this is where I said we make it extremely easy, not just for the developers, but even for the business users and the business analysts. They can literally play with the data. So they can load a sample set of data and start looking at how the data profile or the data distribution is. So for example, in this New York taxi right here, I can see all these different columns. I can also see how these different data sets within each attribute are all distributed. I can also start interacting with this data set right here and start building my pipeline. So for example, if you see here, I already identified a few criteria and I started playing with it. In order to do any kind of machine learning imputation, I dragged in a Python operator. I can right click on it and I can see what that Python script is. So this is a Python script for data imputation. So if you observe here, for a moment, my fair amount has certain null values. This is when I just read my data, but the moment I execute my logic of data imputation on that sample set, we'll observe that the fair amount, there are no longer any null values available. All the null values have now been predicted by that Python model and have been put in with some value to it. So you can, and this is purely an example, you could be using different kinds of algorithms to achieve the same thing. You can even use machine learning on the UI in a visual fashion to do anomaly detection or recommendation, whatever your use case could be. This is an example of a join operator. Again, the whole idea is we make the entire workflow building on Spark so much user-friendly and UI-driven that you really do not even feel for a moment that you're actually building something for a big data technology. Like literally, I had two different tables that I wanted to join. I had the pickup location ID coming in as one of my input sources. A database table had mapping of those location IDs to different boroughs and zones in the city. So I literally just drag drop and made that connection, and boom, I am now able to get all that additional information blended with the data that I just read in. So now I can not just see my location ID, I can also get my location ID, what that pickup borough was, which zone it falls into, so on and so forth. So I can.
This is looking like a convenient BI tool and the workflow tool that even my business can use. And is it really Spark under this?
All of this is happening on Spark, and that's the beauty of this. I'm glad you mentioned it. As you keep dragging an operator, as you keep configuring an operator, that logic instantly, in matter of milliseconds to seconds, gets applied on that sample data set, and you see the result on this pane here. So essentially, it's like an interactive debugging and developing on the UI. Typically, developers would be building all of this on an IDE of their choice, like Eclipse, building a fat jar, submitting it to a Spark cluster, scanning through the logs to validate validate the correctness of their logic and all that. However, Stream Analytics makes that all much more simpler. You validate your logic on the UI, you write your logic, we execute that on Spark behind the scenes for you, and we display that logic right out there up front on this visual pane right here, and you can validate. If you think your logic doesn't make sense, you got some erroneous results, go back, reconfigure, change your logic, again, simply re-inspect, and you see your output right then and there. So
it's almost like what, I've seen a few demos where they call this thing called notebooks, where they interactively interact with Spark on a command line.
That is true, but the difference is in notebook you are still supposed to write code.
Okay.
Here you're not writing code.
But it's the same interactive.
But the interactivity pattern is exactly the same.
So visual notebook for Spark?
That's a good way of calling it. I didn't think about it like that. But yeah, you could think of that as a visual notebook or a visual recipe for Spark.
Wow.
So there are a bunch of different operators. Here's another example of data quality. You can apply data quality rules on the data that you're getting. And again, simply visually choose the field on which you want to apply some data quality operation. And here are different kinds of options that you get based on what data type that particular field has. And once you apply your rules, you have different actions as an option. For example, if the passenger count is 0, do you think that's an error record? Do you want to send it to the error queue? Do you want to assign some default value, or simply ignore that record and just move forward? So you can do all of that here. Here's another example of.
So as Puneet is explaining to us all of this, I want to talk to Puneet, I want to talk to our friends here who are listening, right? So if you are having some questions about Spark, what it can do, what it can't do, feel free to please send us those questions on your Q&A panel. We will be answering that live after this demo. So ensure that we will literally answer every question we get. So feel free to put your questions in, and we will interact with you in a few minutes.
What I just did was I interacted with that data pane. So even without really figuring out how to write a script or invoke a function for replacing a particular string in my value, I simply just clicked on this column here. For example, in the pickup borough, there was Manhattan, and I wanted to replace Manhattan with ABC. So I just went here, I simply went transform, and I clicked replace. The moment I did that, I can see the result instantaneously. And if I go to my data prep steps, I can also see this is how it did that. So as I keep interacting with my data, automatically the logic starts getting built. This is what we are calling it as a data first approach. So as you keep building or interacting with your data, the logic keeps getting built. You can always alter that. I can simply click on this cross if I do not like the result. I can also alternatively right click on that particular operator where this logic resides. I can go ahead and change here directly as well. If you see here a long list of different functions that I could be using, so these are all different transformational functions that I could be applying on the incoming data to get the desired transformation for my data lake. There's also support for aggregation. So here, after I do my data quality, transformation, all of that. I'm writing the raw data into Elasticsearch and also forking it out to calculate and do some aggregations. For example, I want to do a sum total of all the fair amount that I receive between a particular pickup and a drop-off. So I get to know which is the most expensive or the most busy route in the city today. So I can do all of that again visually on the UI. So I hope this gives you a quick overview and a glimpse of how powerful a visual IDE for Spark can really make building workflows and pipelines on Spark easy.
Wow. I mean, I'm actually pretty overwhelmed because this is a lot of functionality here. So are you able to also do monitoring? And, you know, there are some of my users who are power users who hate UIs and they want to do notebooks. Can you do that?
Yeah, absolutely. And we have Notebook integrated into the product. So we have the entire Python. Let me share my screen once again. That entire Python imputation logic that you saw, that was predicting the values as the data kept coming in, right? And of course, before you start predicting, you also need a training model or a model that's trained on a larger data set so it can figure out how to predict when a certain pattern of data emerges or comes up. And so for that, we integrated Jupyter as the notebook choice. It's a very popular amongst data scientists. So you have a complete notebook integration inside of Streamatics where you can write your own model building workflows. And the good part is it offers a seamless experience about transferring your model once built to be used on the canvas for operationalizing it. So if you'll see quickly over here on the top, we offer certain APIs. So for example, if you simply say SAX utils, save and download the model, it automatically becomes available as an operator on the canvas. So imagine your data scientist using the Stream Analytics notebook powered by Jupyter, building his model.
Okay.
And once that model has been built, at the end, simply saying publish this model, and he's all done.
It becomes an object in the UI?
It becomes an object on the UI. The IT team comes in, the team responsible for operationalizing that model, putting it on scale, running it and managing it on the production cluster. That team comes in, that model becomes an operator they drag on the canvas.
Wow.
It's that easy.
So what you're telling me is I got power users who can come in and use the notebook and do everything they want to do, and business users who want to use the UI or higher level users who want to use the UI, and both of that can interact.
Absolutely.
So once I get all this done and deploy it to Spark, I mean, one of my biggest issues is going to be operations, right? I got to keep the lights on, I got to see alerting, I got to see monitoring. Is that covered as well in the product, or?
Yeah, absolutely. And of course, the entire life cycle of Spark workflows is something that the product caters to. So earlier we saw developing or designing a workflow in an interactive fashion, so you can literally debug on the UI while you are building it. Once you build it, this is another view in the product, which is the data pipeline listing page. So every tile here represents a workflow or a job that you have built. It could be streaming or batch again. The moment you click start, it gets submitted to a cluster. And once it's on the cluster, Stream Analytics will also monitor and manage. It will show you different statistics of how many records it has processed, if it's a bad job, and so forth. If the pipeline crashes for some reason, it will alert. It also has the ability to restart. So if it happens in the middle of the night, worst case, you would definitely want to be informed, but you would also want the system to proactively simply resubmit it for a couple of times before completely shutting off. Another thing is, let's take, and these are all the different options. You can schedule a pipeline, you can download or push it to a higher environment. You can, of course, also see the history. The stats notification gives you more information about the monitoring aspects. The history tells you all about how and when the pipeline started, how long it took. So for example, if you see here, about 8.8 million records took 7 minutes to process. You can take a look at the application logs. You can also click on view details to see the data profiling. Now, this is something which is very common with ETL kind of use cases, where you're moving your data from one source to a target. And usually the questions asked are, how can I guarantee that all my data which was on source has been moved to target correctly? Also, please show me the data distribution of that once it lands into target. So all that data profiling and data movement and data validation, checksum validation is built into the platform to take care of.
Wow. So this seems to be a pretty comprehensive solution to make Spark easy to use for my various stakeholders in our bank, for sure. Yeah, I'm trying to digest all of this information, right? So now, I have a lot of questions that from myself as well as what I probably am thinking from my user's point of view, right? So before that, I'd like to actually recap everything we heard today. You told me that point solution vendors is a problem, so I got to consider that. And you're kind of beginning to convince me that Apache Spark is a great candidate for consolidating all our data prep and compute workloads, right? And it seems to me that I can actually get a lot more bang for the buck for all our big data and cloud investments because I can use this platform or this Spark plus this tooling around it as an end-to-end data processing tool as a solution. And it looks like, Stream Analytics from Impetus Technologies is actually really going to solve my problems. I'll have to obviously take it through a real POC or something like that, and it seems like I can use ingest, cleansing, data quality, blending, transformation, analytics, loading, visualizing, all are pretty much covered on one UI here. So I'm hoping our friends in the audience also got that perception and kind of share that view. We do have another poll so that we can have our audience also respond to some of this. Pankaj?
Thank you, Anand, and thank you, Puneet. Before we open the floor for questions in less than a minute, I'm requesting our audience to respond to the poll question and the feedback for the webinar today. The poll is on your screens now, and please respond if you agree that the Apache Spark is a strong candidate to be the enterprise data processing backbone as we shared today in the webinar today. And then would you be interested in a deeper dive for the Stream Analytics product, a visual platform for Apache Spark, and then your webinar rating for today's session. We'll now jump into the Q&A session. We have already received few. Avi, you can see them on your screen. Please go ahead.
Yeah, sure. We got a question here saying, how do you promote this code to either UAT and production environment? What is the prerequisite for this product implementation? So do the developers need to know any language for the debugging and fixing any errors? So we can promote this whole pipeline to multiple environments using the import and export function. We're also actually integrating with CI/CD environment in our next version, so that can actually interact directly with your configuration management, release management setup.
That's right, yeah.
If you want to handle this prerequisite for the product implementation, do developers need to know any language for the debugging, et cetera? Can you handle that?
Sure. So Stream Analytics supports gathering of all your errors and logs and bringing them to a single place. Literally, the developers who are building an application or a pipeline don't need any SSH access or anything to those machines with Spark running. The whole objective is once you log into Stream Analytics, your entire life cycle, all the way from building to managing, monitoring, debugging can happen through the UI itself. So any errors that the application has during processing, you can see all of those on the UI. You can search those just like you would do with any log monitoring tool. You can search for those errors and find out what they are. You have the ability to also fix those errors, again, using that visual canvas. We also support versioning of these pipelines. So as you start drag dropping operators and you build them, you can version those. So for example, if version 1 has been running fine in production, but when you deploy 1.1, you run into a lot of errors. While you fix those, you can immediately at least roll back to the older version so that the system continues to remain on and processing. As part of developers' language, we support all three. You can write code and you can write your scripts in either Scala, Java, or Python. The platform supports all three.
Okay. Well, can you monitor Spark streaming jobs?
we have a full-fledged monitoring built into the platform, may it be batch or streaming pipelines for both, depending upon, of course, what those jobs are, whether it's batch or streaming, the kind of monitoring you would see is different. Specifically for Spark streaming jobs, yes, we support monitoring of that. We read in all the stats at runtime. So as the streaming job continues to process data, we keep reading the statistics of what that processing is. So for example, let's say you're reading data from Kafka and doing some transformation and things like that. We monitor at what rate is the pipeline or the job reading from Kafka. We also monitor at what rate the data is getting written or landing into the Kafka. So at any point in time, you can actually see if your job is lagging or is it pretty much at par on the rate at which data is coming in, is the rate at which it is processing. So you can see all of that. The system also keeps monitoring for any application error logs. So if there are any errors that occur during the processing, the system will gather all of those, also send out an email as an alert. All the monitoring stats can be configured as different alerts. So proactively the system can monitor, and the moment it sees any issues, it can go ahead and start alerting and sending out emails for that.
I think there's another very, very interesting question, which is something we should have probably handled in the demo itself. How do we set up dependencies? So if I have multiple jobs and I need to set up dependencies between them and make sure they're not running concurrently, one gets over, the other one starts, etc. How do I set that up here?
We have a full-fledged workflow orchestration built into the platform. So there are actually two aspects. One is, how can we schedule this? So if it's a single job that you would want to schedule, you can just give in a cron expression kind of the scheduling parameter. So we simply will take that cron expression and schedule that job. So if you say run this job every 6 hours, that's how it would get scheduled and executed. If you have multi-job dependencies that, hey, run a job A, if job A is successful, trigger job B, if job B is successful, trigger job C, and so forth, or if either one of the fails, do not trigger any of the downstream jobs, you can build that entire dependency again visually. We support two different workflow orchestration engines to do that. Depending on your environment, you could choose Oozie as your workflow orchestration, or you could use Airflow as an alternate for your workflow orchestration. So using either of these workflow orchestration tools, you can do your multi-job scheduling, again, visually on Stream Analytics. So you don't need to create an Oozie workflow XML outside of Stream Analytics. Stream Analytics provides a canvas where you drag drop all these different jobs and connect them in the order of their dependencies and provide your condition and criteria. Behind the scenes, we automatically create the Oozie workflow for that.
So there's a clarification from one of the audience saying what I meant was especially error messaging and debugging, right?
Mm-hmm.
So when we get error messages, something similar to Java, would we get it? Because when we use Talend, we get some kind of Java type of issues, and ab initio, we need to have shell scripting knowledge to know what the error is. So how do I, as a coder, as a Spark developer, how am I exactly seeing my errors?
We would wrap those errors with some meaningful information. However, at the end, at the core level, you would still have the Java stack trace available and accessible to you. And in order to really debug at that level, you would need some amount of Spark and Java knowledge to understand what that error is and how to fix it. For most part, there will be meaningful information, and if you are building the pipeline and during the design stage, if you make any errors, like let's say, for example, you're connecting two different incompatible Spark APIs together. Let's hypothetically, if you're connecting a data frame output to an RDD input, the system won't let you do that. So there's some amount of proactive handling on the UI where you are trying to connect incompatible operators together. But if you have a valid workflow or a job submitted, and if something goes into an error mode there, you have access to that stack trace, but you would still need some Java and Spark knowledge to debug through that.
Got it. So there's a question that we see often also, can this be deployed on Databricks? And I'll expand that question. Can this be deployed on Apache Spark, AWS, Azure, Databricks, any of these or all of these? What is the answer?
We support all the three. So if let's say, for example, you are using Databricks as your Spark provider, Stream Analytics works with the Databricks APIs, and it gives you the full cluster view. You can spin up clusters on demand. You can execute or attach a particular job to a particular cluster, and once the job finishes, you can kill that cluster automatically. So all of that scaling up, down, ability to run on Databricks-powered Spark cluster is fully supported and available in Stream Analytics. So you can literally create, just how you create clusters on the Databricks and attach your notebook to it, similarly you would create Databricks clusters from Stream Analytics and attach your job to it.
All right, thank you very much, Puneet and Anand. I think we've already overrun on the scheduled time. We have a few more questions still coming in, and we'll be taking them up on the email later, and please look forward to that. And we thank you once again for joining us today. Feel free to go to the streamanalytics.com website for a free download of Stream Analytics Lite or the cloud-based version, or you can send us an email on inquiry@streamanalytics.com for any other questions you may have. Thank you once again for joining us today. Have a great rest of the day. Thank you.